There is this nice new report by the IEA, International Energy Agency, on the role of the critical minerals in clean energy transitions. We are relying heavily on the promise of electrifying everything in the future to meet our global warming targets of 2 degrees C and 1.5 degrees C and so on. We also rely on technological promises from bioenergy and carbon capture, which we have talked about elsewhere. This is a very big report. As usual, I'm going to provide a very brief summary, maybe in 2 podcasts. And let's start by reading the main message. An energy system powered by let me get the pointer here. An energy system powered by clean energy technologies differs profoundly from one fueled by traditional hydrocarbon resources. Building solar photovoltaic plants, wind farms and electric vehicles generally requires more minerals than their fossil fuel based counterparts. A typical electric car requires 6 times the mineral inputs of a conventional car, and an onshore wind plant requires 9 times more mineral resources than a gas-fired power plant. Since 2010, the average amount of minerals needed for a new unit of power generation capacity has increased by 50% as the share of renewables has risen. Okay, so we'll keep running between looking at graphs, data, and some text which highlight the key policy points, market points, and other details. Starting with this one, a rapid deployment of clean energy technologies as part of energy transitions implies a significant increase in demand for minerals. So typically we are talking about copper, lithium, nickel, manganese, cobalt, graphite, chromium, molybdenum, zinc, rare earths, silicon, and others. So we have sectors like transport and power generation, 2 big items. So here, kilograms per vehicle, electric car, as we said, 6 times more minerals than a internal combustion engine, and it has all these minerals required here, and a conventional car is sitting here with mainly copper and manganese. Okay, power generation in kilograms per megawatt. Offshore wind, again relying a lot on copper. Onshore wind, solar PV requires a lot of silicon right now, but newer materials are always being sought. Nuclear requires rare earths, of course, and coal, as well as natural gas, and you can see the numbers here in terms of either kilograms per vehicle here and kilograms per megawatt over here. The energy sector becomes a leading consumer of minerals as energy transitions accelerate. So typically the report is looking at the stated energy policies and sustainable development scenario, and we are looking at 2010 to 2040 by decade, and you can see the share of clean energy technologies in total demand for selected minerals. So we have gone from lithium having basically baseline of 100% to not much dependence there, to growing to almost 25% here, or 30%, and in the stated energy policy scenario by 2040 we'll jump to close to 80% of the 2010 baseline, and 2040 we are going to jump to more of the almost 90% here. So this is as a part of the total demand for select minerals, not the baseline of 2010. Sorry, never mind that, scratch that. Okay, cobalt, nickel, copper, rare earths, you can see all of them essentially are going to take more and more share of the clean energy technologies in total demand for selected minerals, what fraction they occupy. Mineral demand for clean energy technologies would rise by at least 4 times by 2040 to meet climate goals, with particularly high growth for EV related minerals. We'll look at climate impacts a little bit later on. Mineral demand for clean energy technologies by scenario. So 2020 here, definitely baseline, but we are looking at hydrogen, electricity networks, EVs, and battery storage, other low carbon power generation, wind and solar PV. So it's looking at million tons in growth to 2040 by sector, again looking at sustainable development scenario here, and net zero by 2050. So we're going to jump to 4 times by 2040 for the sustainable development scenario, and for net zero by 2050 we have to jump by 6 times in terms of mineral demand for clean energy technologies. Okay, growth of selected minerals in the sustainable development scenario 2040 relative to 2020. Again, index is 1 for 2020, so lithium 42 times, graphite, cobalt, nickel, and rare earths. Is this bad news? Not necessarily. We'll see that there is enough resource available for each of these minerals. There are details of what that means. Just because they are geologically available, does that transition to a easy ride to energy transitions? We'll see that. Changing fortunes, coal versus energy transition minerals. So just compare, coal is sitting here in 2020 in terms of billions of dollars pegged to 2019. So energy transition minerals here, coal versus energy transition minerals in 2030, and then coal drops significantly compared to energy transition minerals by 2040. Again, we are looking at the list of minerals that we have been talking about. There are lots of details in each of these graphs with the footnotes, but which I'm not reading, but you should definitely go to the report and read them. So, to make a few more points, today's mineral supply and investment plans fall short of what is needed to transform the energy sector, raising the risk of delayed or more expensive energy transitions. We've talked about before in another podcast where we have seen that faster the transition to clean energy, lower will be the embedded emissions in the transition itself, all the infrastructure needed and so on. Main points, again, I'll just read off the bold-faced text. High geographical concentration of production. We'll see some figures for this. Long project development lead times. So I won't show a figure on this, but our analysis suggests that it has taken an average of over 16 years to move mining projects from discovery to first production. So these are things we have to worry about in terms of planning and being ready for the transition in terms of availability of minerals, right? Declining resource quality. This is the other side of the coin of resources being available, but the ore quality, for example, being not high enough, which requires more energy for processing, for example. Growing scrutiny of environmental and social performance. So the ESG targets have to be kept in mind as well, environmental, social, and governance issues, which are not trivial. Higher exposure to climate risks, so water and air quality impacts of mining are always something we have to keep in mind. Coming back to some more data, production of many energy transition minerals today is more geographically concentrated than that of oil or natural gas. Okay, this has already been a problem, especially in the context of Russian invasion of Ukraine, which we have talked about already in multiple podcasts. So here, looking at share of top 3 producing countries in production of selected minerals and fossil fuels in 2019. Here, in terms of extraction, fossil fuels, natural gas and oil, US dominates, but there are others like Russia and Saudi Arabia. Copper, nickel, cobalt, China, rare earths and lithium, and you can see the dominance by Chile here, Indonesia, Democratic Republic of Congo, China, and Australia. In terms of processing, so both matter, where they are extracted and where the processing happens. So for fossil fuels, oil refining and LNG, US and this one is Peru are big, maybe China, are big players. In LNG export, Qatar and Australia are big players. For all these minerals, China is a substantially big player in terms of processing. So this is already beginning to be noticed by the US in terms of its own climate plans versus how China is cooperating with Russia on the invasion of Ukraine, and how chip shortage, etc., are playing out, and how US wants to become secure in all these areas. The projected surge in spent battery volume suggests immense scope for recycling. So recycling is going to be a big contributor to reducing mineral mining, as well as relying on imports because of these concentrated extraction and processing. Amount of spent lithium-ion batteries from EVs and storage and recycled and reused minerals from batteries in the sustainable development scenario in gigawatt hours. Amount of spent batteries in gigawatt hours jumps very quickly to 2040, with electric cars dominating, with others like energy storage, electric trucks and electric buses, and electric 2 and 3 wheelers adding on top. In terms of recycled and reused volume, where we should be compared to 2030 and 2040 in terms of kilotons. So this is cobalt, nickel, lithium, copper, and share of total demand. So there is the right axis here in terms of the percentages. So you can see that we have to recycle and increase the reused volume by a lot by 2040. 2030 is right around the corner, so plants have to start ramping up right now. Stronger actions are required to counter the upward pressure on emissions from mineral production, but the climate advantages of clean energy technologies remain unclear. This is a big caveat here. Climate advantages of clean energy technologies remain unclear. Okay, so tons of CO2 equivalent per ton of metal, average greenhouse gas emissions intensity for production of selected commodities. So there is the mineral requirements and then how that translates to reduced emissions, right? So in terms of processing, mining for iron, zinc, refined copper, lithium carbonate, class 1 nickel, aluminum and cobalt sulfate, you can see that processing is a big part for some of them and mining is a bigger part in terms of emissions for some others. If you look at life cycle greenhouse gas emissions of a battery electric vehicles and internal combustion engine vehicle in terms of tons of CO2 equivalent, so these also CO2 equivalent, so also includes non-CO2 greenhouse gases using the transformation based on greenhouse warming potential, which we have talked about elsewhere, and you can look up if you are not sure. So this is tons of CO2 equivalent per vehicle lifetime for battery electric vehicles and internal combustion engines. So obviously life cycle greenhouse gas emissions are lower in this case compared to ICE, where the fuel cycle well-to-wheel is a huge contributor for ICEs. We have also seen the co-benefits in terms of housing prices, air quality, health, etc. of the battery-operated electric vehicles. So that's always important to keep in mind. Before we move on, let's look at IEA's 6 key recommendations for a new comprehensive approach to mineral security. We'll come back and look at some more details in the next podcast since this is getting long enough. Ensure adequate investment in diversified sources of new supply. Sounds like a no-brainer, but important to codify it. Promote technology innovation at all points along the value chain, from processing to extraction to end use and recycling. Scale up recycling, so that's always critical. Enhance supply chain resilience and market transparency. So this is critical in terms of how little geopolitical perturbations tend to spook the markets and then throw them off balance for several years, as is happening with the fossil fuel market and renewable ramp up after the Russian invasion. Mainstream higher environmental, social and governance standards. So this is something that governments, corporations have to take into account. Strengthen international collaboration between producers and consumers. Again, these are easier said than done, but such an initiative could include actions to provide reliable and transparent data, conduct regular assessment of potential vulnerabilities of supply chains and potential collective responses, promote knowledge transfer and capacity building to spread sustainable and responsible development practices, and finally strengthen environmental and social performance standards to ensure a level playing field. So how the developing world will get affected by these transitions are critical. We have talked before about the social perception and behavioral change required along the way, and how these are country dependent, and then there is the issue of meeting global warming targets and how everybody has to be part of the solution. But unless there are equitable or equal access to markets, minerals, transitions, technologies, etc., everybody is going to pay a price, which has become more and more clear now with extremes hitting pretty much every country across, which are not immune from the climate change impacts on extremes, rainfall, droughts, wildfires, diseases, and so on. Okay.